This video is on subsets and power sets. A set A is a subset of a set B if every element in A is also an element of B. And that's denoted A is a subset of B, so that's our subset symbol right there. So for example, for the two sets, C is the set containing the elements 1 and 3, and D is the set containing the elements 1, 2, and 3. Then it's true that C is a subset of D, and it's also true that D is not a subset of C. So just like with element of and not an element of, we use sort of a slash through the subset sign to show that one set is not an element, a subset of another. So here are just two quick ones to look at. Is the set containing 1 and 3 a subset of itself? And is the empty set a subset of the set containing 1 and 3? So just pause quickly and think about those. Okay, so is the set containing 1 and 3 a subset of itself? Well, the question is each element of the first set also an element of the second? So 1 is in the first set and it's in the second set? Yes. 3 is in the first set and it's in the second set? Yes. So yes, this set is a subset of itself. And in general, for any set A is always going to be a subset of itself, no matter what. Is the empty set a subset of the set containing 1 and 3? Well, let's check all the elements of the empty set. The empty set has no elements. So is any element that is in the empty set also in the set containing 1 and 3? Yes, it is true that any element that is in the first set is in the second set. This is something that we say is vacuously true. So my usual example is, are all of the elephants in the room that you're sitting in pink? And for myself, there are no elephants in the room that I'm sitting in. So are all the elephants in this room pink? Yes, this is a vacuously true statement. Similarly, is the empty set a subset of the set containing 1 and 3? Is every element in the empty set also in the set containing 1 and 3? Yes. There are no elements to check, so this is a vacuously true statement. So for any set A is a subset of itself, and the empty set is a subset of any set A. Here's another quick problem for you to try. So I'd like you to write out the set below by including all of its elements between braces. So, you'll use braces like this and then write out each of the elements that would be in this set. So I'm not going to read it out loud because, again, that's part of it. I'd like you to be able to read and interpret all those symbols. So I'm going to pause and let you try writing that out on a piece of paper. Okay, so we're writing out the set by including these elements between braces. It's all sets. Since this is a capital X, we sort of assume that it's a set, and we are confirming that it's a set because we're saying things that are subsets of, so X must be a set. Sets X that are subsets of the set containing A, B, and C, such that the cardinality of X is equal to 2. So what are things like that? Well, the set A, comma B is a subset of that set, and the set A, comma B has 2 elements, so that fits the criteria. The set A, comma C would also fit that criteria, as would the set A, comma D, and the set B, comma C, the set B, comma D, and the set C, comma D. So those are all sets that fit that criteria. 2 more to try. I'd like you to list all of the subsets of the set C containing the elements 1, 4, and 9. I'd like you also to list all of the subsets of the set containing the empty set and the integers. So again, pause, try those out quickly. All right, so all of the subsets of the set containing 1, 4, and 9. So we're listing these subsets out. The empty set is a subset of any set, so we can list that. The entire set C is also a subset of any set. or the entire set itself is also a subset. And what else have we got? Well, we've got the set containing just the element 1, the set containing just the element 4, the set containing just the element 9. So those are all singleton sets. We've also got all the sets with 2 elements. 1 and 4 would be one set with 2 elements. 1 and 9 would be another set with 2 elements. And 4 and 9 would be a last set with 2 elements. So this happens to have 8 subsets. There are 8 distinct subsets of the set C equals 1, 4, and 9. So let's also list all the subsets of the set containing the empty set and the set of all integers. So again, the empty set itself is going to be a subset of it. The entire set empty set, integers, that is a subset of itself. So that's going to be another one of these subsets. What else? Well, this is an element. So the set containing just the empty set is also a subset of that. And this is also an element. So the set containing the set of all integers is also a subset. So those are our 4 subsets. Notice that even though, the integers, the set of all integers is an element of the set containing the empty set as well as the set of integers. For example, the set containing 1 and 4 is a subset of the integers, but the set containing 1 and 4 is not a subset of this set right here, is not a subset of the set containing the empty set and the integers, because the set containing 1 and 4 is not itself an element of that set. So there's a special name for the kind of thing we were just doing, listing all the subsets of a set, and that is the power set. So if A is a set, the power set of A is the set of all subsets of A, and it's denoted curly P of A. So P of A, the power set of A. So as we just saw above, the power set of the set containing the empty set and the set of integers is the set of 4 elements, the empty set, the set containing the empty set, the set of the set containing the set of integers, and the set containing the empty set and the set of integers. That's the power set of that set above. So here are 2 quick examples for you to try. What is the power set of the empty set? And if A is a set with n elements, what is the cardinality of the power set of A? How many elements does the power set of A have? So again, pause and just think about those for a moment. So what is the power set of the empty set? So the power set itself is a set. It's going to have braces around it. The empty set is a subset of every set, so it's a subset of the empty set. And any set is a subset of itself. Again, that would just give us that the empty set is a subset of itself. Are there any other subsets of the empty set? No, only itself. So that is the power set of the empty set. If A is a set with n elements, what is the cardinality of the power set of A? So let's let A be equal to the set containing A1, A2, ... up through AN. Those are these n elements, whatever they happen to be. And for each of the n elements of A, there are 2 choices. So A1 is in subset or not, and A2 is in the subset or not, and A3 is in the subset or not, etc. So we have 2 choices for each element of A when we select a subset. Either this is in or out of the subset. So the number of possible subsets is, we have 2 choices for the first element, and so times 2 choices for the next element, and 2 choices for the next, ... and 2 choices for the last element. So therefore, the number of possible subsets is 2 to the nth power. Here's the last set of problems for this video. I'd like you to find or describe the following sets. And if they do not exist as sets, just say so. So again, I'm not going to read them out loud because interpreting those, reading those is part of what I'd like you to be learning. So try those out, pause, write out those sets or say that they are not sets, and we'll talk about them together. Okay, so the power set of the set containing A, the set BC. What are the set of all subsets of this set? So it's the set of all subsets. It's going to have braces around it. And one subset of that set is the set containing just A. Another subset of that set is the set containing just the set B, comma, C. Another subset would be the entire set. So A, comma, set containing B and C. And the last subset would be the thing that's a subset of every set, the empty set. So note that this power set has 4 elements, and the original set had 2 elements. So that original set had 2 elements, the element A and the set B, comma, C. So yes, here we had 2 to the second is 4 elements in the power set. All right, power set of the number 4. So remember that the definition of the power set is if A is a set, the power set of A is the set of all subsets of A. This is not a set. So the number 4 is not a set. This power set does not exist. If we were instead asked, what's the power set of the set containing 4, then that is a question we could answer. And the power set containing 4 would have the empty set, subset of every set, and the set itself, and that would be it. Again, this would have 2 elements, and that's 2 to the 1. This has 1 element. But if something is not a set, we cannot take the power set of it. Power set of the real numbers squared. That's the same thing as the power set of our Cartesian product with itself. So that is a set. We're saying, what's the power set of the whole xy plane? So that's something we cannot list out. This has infinitely many elements, infinitely many subsets of the xy plane. And so, anything you could draw, like here I'm going to draw a terrible bunny, so this is not a very good bunny, but that is my bunny, and that is technically a subset of R cross R, right? That set of lines right there is a subset of R cross R. What else is this squiggle right there, and the word hello, and a heart? Those are all subsets of R cross R. So clearly I cannot list out all infinitely many, subsets of a plane, but the book mentions this set actually, and it's kind of poetic. It says every word in every book ever written every book ever written really is a subset of R cross R, because you could just think of the book as laying out all these pages on one huge Cartesian plane. That is a subset of R cross R. So yeah, it's this kind of unimaginably infinite set. All right, and finally the power set of the set containing A. We're going to do these one at a time, so we're going to sort of unwrap these one at a time. First, we'll think of this as the power set of of A. So the power set of the set A has the empty set, and it has the set itself. Those are all the subsets of the set A. And now we're going to take the power set of that. So the power set of that has the empty set. The empty set itself is also an element, so it also has the set containing the empty set. It has the set containing the set A. So since the set A is an element, notice we need 2 sets of braces here. And lastly, we have the entire set, the set containing the empty set, as well as the set A. So this would be the power set of A.